Good day everyone, I am Christian G. Costan and I will be discuss the measure of relationship and the measure of relative position. Measures of relationship describe the degree of relationship or correlation between two variables, academic achievement and motivation. It is expressed in terms of correlation coefficient from -1 to 0 to +1. Measures of relationship are used to indicate the degree to which two sets of scores covariate are related. We intuitively seek relationship by such statement as if high score in variable x tend to be associated with high score on variable y, then the variables are related, or if high score of variable x tend to be associated with low score on variable y, then the variables are related. Relationship can either positive or negative and either strong or weak. Letter A. Person R. Most appropriate measure of correlation when sets of data are interval or ratio type. Most stable measure of correlation used when the correlation between the two variables is a linear one. The person R is the most widely used measure of relationship. The person R is calculated to show the linear relationship between two variables. To compute the person R, two measures on each subjects are needed. The person product moment correlation, or the person R, was advised by Carl Person in 1895, and it is still the most widely used correlation coefficient. The person product moment correlation, or person R, is an index of the degree of linear relationship between two variables that are both measured on at least and ordinal scales of measurement. So, you may see the picture below. The ordinal scales of measurement from 0 to the left is a perfect negative relationship, while the other hand, the 0 to the right is the perfect positive relationship. Letter B. Spearman rank order correlation, or Spearman row. Most appropriate measure of correlation when variables are expressed as ranks instead of score, or when the data represent an order scale. Spearman row is also interpreted in the same way as person R. It provides an index of degree of linear relation between two variables that are both measured on at least an ordinal scale of measurement. It is the same range as the person correlation, and the numbers mean the same thing. We can also derive using the person man rank formula, which is the R sub S is equals to 1 minus 6 submission to D squared over N quantity of N squared minus 1. The lowercase r with a subscript s is used to designate the Spearman correlation. The one term in the formula that is not familiar with us is D, which is equals to the difference in the ranks for the two variables. This is explained in more detail in the section that R covers the manual computation of Spearman rank order correlation. So next, measure of relative position indicate where a score is in relation to all scores in the distribution. They make it possible to compare the performance of an individual in two or more different tests. Relative position measures a value that is related to another values in data distribution. The most common measure of position are percentiles, standard score, STA9, and T-scores. Measures of position helps to identify where a value falls in the data set. It lets us know whether a value is average or unusually low or high. A measure of position determines the position of a single value in relation to another values in a sample. First, letter A, percentile ranks, indicates the percentage of score that fall below a given score, appropriate for a data representing ordinal scale, although frequently computed for interval data. Thus, the median of set of score corresponds the 50th percentiles. The items in the data distribution are arranged from ascending to descending order. The values that divide the items into 100 equal parts are called percentiles. When looking at the percentiles rank on the specific data value, we can see percentage of the data that is found below or up to that value. Therefore, percentiles do not necessarily lay equally separated on a distribution. In order to calculate the percentile of a certain value of x from the dataset, we follow the next formula. Percentile of x equals number of data points less than x divided by total number of data points times 100. Letter B. Standard scores. A measure of relative position which is appropriate when the data represent an interval or ratio scale. As a z-score expresses how far a score is from the mean in terms of standard deviation units. Allow all score from different tests to be compared. In cases of negative values, transform z-score to t-score. Multiply z-score by 10 plus 50. Standard score is a set of scores that have the same mean and standard deviation, so they can be compared. Standard scores are all measured on a universal scale, which counts the number of standard deviation between a raw score and the mean value. The relative size of values from different data sets can be fairly compared by using standard score instead. A standard score or a z-score shows how many standard deviation an item is from the mean. So the picture below is the formula of the standard score, where z represents the z-score, x is the data value, the macro is the mean of the data set, and the sigma is the standard deviation. So next, letter C, STAN9 scores. Standard scores that tell location of a row score in a specific segment in a normal distribution, which is divided into 9 segments, numbered from a low of 1 through a high of 91. Scoring falling within the boundaries of these segments are assigned one of these 9 numbers, standard 9. STAN9 is a method of scaling test scores based on a 9-point scales, and STAN9 is abbreviation of standard 9. A STAN9 score is a way to compare or scale a group of score to one another using scoring format that range from 1 to 9. A STAN9 score of 1 to 3 is considered below average. A STAN9 score of 4 to 6 is considered average, and STAN9 score of 7 to 9 is considered above average. Although STAN9s provide the same information as the other standard scores, they are less accurate. For example, in the table below, only STAN9s 4 to 5 and 6 within an average range of classification. However, within the standard score table below the STAN9 table, this is a range of score from 90 to 109. So the last is t-scores. Tells the location of score in a normal distribution having a mean of 50 and a standard deviation of 10. A t-scores is equivalent to number of standard deviations away from the mean of the t-distributions. The t-scores is the statistic used in a t-test and regression test. It can also be used to describe how far from the mean an observation and when data follow a t-distribution. Therefore, a t-score is a standardized way that scores are represented to make them easier to understand. The image below shows the normal distribution labeled with the different scales for interpretation. That's all. Thank you for listening and God bless.